you done the physiology of it yet?
No.
Because you have to understand the physiology of gastric secretion. There are a number of receptors on this parietal cell. The vagus that you've been seeing is important in stimulation of the acid cell from this. When you become tense and nervous and stressed out, as it is in the exam and so, you produce more acid. And that's because of overactivity from the brain coming down through the vagus. And the transmitter here is acetylcholine. So on the surface of this parietal cell is a cholinergic receptor. Yes? So you need to understand that. On the surface of the cell is another called histaminic H2 receptor. Yes? There are certain additional cells which need special stains to show you. I don't think Mr. Gardner will have them. There are specialized cells in the stomach, more in the pyloric antral region, called the ECL, enterochromaffin-like cells. And these produce this histaminic type substance that will interact on the H2 receptor on the parietal cell. In addition, in the pyloric antrum, there are certain cells which produce another hormone called gastrin. And gastrin will interact on the gastrin from the G cells. The gastrin will now interact on that parietal cell. Okay, so you see there are 3 receptors on this parietal cell. So in the fundus and body, that's where you have the predominance of the parietal cells which are going to be producing hydrogen ions. Down in the antrum, pyloric antral region, there are no parietal cells. But what you have down there are the cells that will produce the stimulation of these parietal cells. That is histamine and gastrin. You understand that? This is from a anatomic physiological point of view. I will make use of this information because stress will give rise to hyperacidity. It breaks down the defense mechanism of the stomach. You will have heard or will hear that the most important defense mechanism of the stomach against acid is the bicarbonate ion. As you generate hydrogen ions, bicarbonate ions will be produced, CO2 plus H2 in CO3. The bicarbonate ions are the most important defense mechanism against acid. Whatever hydrogen ions back used in the stomach will be neutralized by the bicarb. Yes, the mucus plays an important part as well, but not as important as the bicarb. The pharmacologists, they have made use of this. They have substances called carbenoxyl and sodium that's derived from licorice. You ever heard of that plant, licorice? And this enhances the mucous membrane of the stomach. So we use that. Now, when we need to get inside the parietal cell to understand. We said there are 3 stimulus, yeah? Cholinergic, histaminic, and gastrin. The first 2, cholinergic and histaminic receptors act together. Yes, they result in activation of this enzyme adenine cyclase. You've heard of adenine cyclase? And it splits off an energy bond from ATP to form ADP. And the active phosphate bond will go down to the proton pump and going to pump hydrogen ion from the cell into the lumen. Yeah? The gastrin receptor. The gastrin receptor, when stimulated, will act via an independent pathway from the other 2. So the cholinergic and the histaminic receptors are linked, where the gastrin receptor goes by a different pathway probably splits off energy bond from GTP. Yeah? So it's separate. Now, you'll say, what can we do about this? We have now produced specific cholinergic receptor blockers. Yes? Some of you would have heard about H1 and H2 receptors. Yeah. They have tried to produce specific cholinergic receptors here. But what they are using more are the specific H2 receptor blockers. Follow me now? They have the H2 receptor blockers. Some of you will have heard about Zantac and all of these drugs. And it blocks the H2 receptor and reduces the activation of the adenine cyclase to get energy bond from ATP. Why not gastrin? The pharmacologists, they have identified gastrin, which you know about, or will know about soon, and they have made blockers like pentagastrin blockers. But they have found in real life, in clinical trials, that the gastrin blockers have no real effect on acid secretion in the stressed individual. And what this is telling you is that the former, the cholinergic histaminic receptor is more important for acid secretion than gastrin.
Excellent.
Now we could talk more about the physiology.
Well, I'm always fascinated with Dr. Lemke and his physiological perspectives. Very good. Now I will go back to and pharmacology. Alright. Now I will go back to basic histology. Okay, so the area that I think is best to start off in the stomach is in the fundus, right? The fundic stomach. So stomach. Remember, stomach is going to have the same layers that we have literally gone over again and again and again. So the stomach, only the outermost covering will be, in this case, what? Serosa. Okay? We know that the stomach has a peritoneal lining, not visceral peritoneum. So therefore, there will be the muscularis externa, the usual muscularis externa. We'll see all of this being the outer longitudinal layer, and then there's an inner circular layer that seems to be the circular layer there, the submucosa. But what I want you to focus on is this layer. And there is also, yes, there are also some strands, not a complete oblique layer, but we'll find that there is an innermost oblique layer, but it's not continuous, okay? And that, for example, some of the major strands will help to form that megastratum in the stomach, okay? Now the mucosa of the stomach, alright, so that's the muscularis mucosae right here. So Rihanna, where's Rihanna? Very good. Well, Miss Penty, look here. So there you can see the what? The muscularis mucosae. Okay? So that's the muscularis mucosae right here. So below here, this is what? Submucosa. Now what I want you to turn your attention to is the fundic stomach. Because the fundic stomach, histologically, is, you'd say, the more exciting of the areas. Okay? In terms of how it looks histologically. So to me, when I was a student, whenever I looked at the fundic stomach, I said it reminded me of a Christmas tree. Lots of bright lights on it. So we see all these bright cells, bright pink cells. And what are these bright pink cells? These are the parietal cells. Okay? So there are two sets of tissues in the body that look like Christmas trees. Alright? Lots of pretty light bulbs on. One is the fundic stomach, and another one you're going to do towards the end of the term, and that is the anterior pituitary, or the adenohypophysis, where we get chromophils and chromophobes, etc., acidophils. So there you can see that the parietal cells are very